In this video, we're going to look at the relationship between solution volumes. So we're going to use stoichiometry and look at solutions. So first things first, we need to get a little vocabulary out of the way. The first word you need to know is titration, and that's a method of chemical analysis that we use to determine the unknown concentration of a substance. So if you make something new in a manufacturing plant and you don't know the exact concentration, you know what you want it to be, but you have to verify that. What we do is we react to that substance that we don't know the concentration of with something we do know the concentration of, and that's called a standard. And then we use that stoichiometric relationship, that mole-to-mole relationship that we've been using in our earlier problems to figure out the unknown concentration. The other thing that you might hear about in titration problems are some things called equivalence point and end point. So when you have a titration, you use an indicator, and we've seen that before. We've used phenolphthalein in class. It's something that changes color depending on how acidic or how basic a solution is. And so when we use the indicator, it can tell us whether we've combined the acid and base in the right proportion. When the indicator changes color, that's called the end point of the titration. So it goes from one color to another, and you know you've reached the point that you want. In the ideal world, that happens when we mix the acid and base in exactly equal proportions. And that's also, that point is known as the equivalence point. So you may hear either one. All right, so let's look at an example problem. In this problem, I'm being asked to find what volume of 6 molar hydrochloric acid is required to completely react with 500 milliliters of 0.0112 potassium hydroxide. So the good news is this problem kind of looks like the ones that we saw in the mole unit, where we have 2 molarities and a volume in the problem. And if you can recall, there's a formula for that on the formulas page of your reference table. It's M1V1 equals M2V2. And this works when we have a monoprotic acid, remember an acid that only has one hydrogen, and a hydroxide. So let's take a look at how to use that in this problem. If we go ahead and call the volume we're trying to find V2, then remember the volume of 6 molar, that would be M2, so 6 molar would be M2. And then we can label 500 milliliters our V1 and 0.0112 molar M1. So we can use our formula, and we're going to solve for V2. So remember that we'll divide both sides by M2. So M1 V1 divided by M2 will give us V2. And then we just substitute in the numbers we've labeled in our equation. You can see I've made a mistake in the formula. It should be 0.0112 molar times 500 milliliters divided by 6 molar. And you can see that those big M's will cancel, and you'll be left with milliliters for your unit. And you should end up with 0.933 milliliters. Remember to try this on your calculator so you know that you're getting it correct. You would multiply 0.112 and 500 and then divide by 6. Let's try another example. In this problem, we're being asked to find what volume of 0.8 molar potassium hydroxide is needed to titrate 15 milliliters of 0.325 molar HCl. And again, we're going to use our same formula, M1V1 equals M2V2. If we go ahead and label that first volume, what volume, the one we're trying to find, as V1, then our molarity, 0.8 molar, would be M1. And then it's asking us to titrate 15 milliliters, that would be V2, of 0.325 molar, which would be M2. So remember that the pairing of those numbers is really important, and you just want to be really careful about it so that it doesn't matter if you call the right pair M1V1 or M2V2, you just want to be sure that they're paired together. And when you plug that into the equation, you get this, and when you plug that into your calculator, you should get 6.09 milliliters. All right, let's go through a couple more. In this equation, it says to calculate the molarity of an acetic acid solution if 34.57 milliliters of this solution are needed to neutralize 25.19 milliliters of 0.1025 molar sodium hydroxide. So if we call the molarity that we're trying to calculate, M1, then that 34.57 will be V1, because you can see that 34.57 of this solution. We're talking about the acetic acid solution. So remember to pick those problems apart pretty carefully. And then 25.19 milliliters would be V2, and 0.1025 molar would be M2. So let's take a look at setting this up. Again, use your formula, M1V1 equals M2V2 from the formulas page of your reference table. And then when we solve for M1, we're going to divide both sides by V1, and it's going to give you M2V2 over V1. And then you'll just substitute in your numbers, so 0.1025 molar times 25.19 milliliters divided by 34.57 milliliters. And you can see that the milliliters will cancel, and we'll be left with molarity for the unit, the big M. And then the answer would be 0.075 molar. Remember to make sure that those volume units cancel. If you have milliliters for one volume unit and liters for the other, remember that you'll have to do a conversion for that. All right, last problem. 38.2 milliliters of 0.437 molar sodium hydroxide was titrated with, remember, reacted with 25.0 milliliters of hydrochloric acid. What was the concentration of the hydrochloric acid used? So let's go ahead and call that first volume in our problem V1, which means the 38.2 milliliters will be V1, and then 0.437 molar will be M1, which makes 25.0 milliliters V2, and that concentration that we're trying to find will be M2. So in this case, we've got the same equation, M1V1 equals M2V2. And we're going to solve that for M2. So we divide both sides by V2, and then M2 equals M1V1 divided by V2. And then we plug in our numbers from our problem. So 0.437 molar times 38.2 milliliters divided by 25.0 milliliters. Remember to make sure those volume units cancel. And when they do, and you put this in your calculator, you should get 0.668 molar. If you have questions, please ask me about it. I'll see you in class.